Okay, welcome back to example 4 for the notes for domain and range of relations and functions. And in example 4, we're focusing in on discrete relations this time. In examples 1 through 3, we were looking at continuous smooth curves or discontinuous functions like rational functions where there was an asymptote causing a break in that smooth curve, but for example 4, discrete relations and functions, those are sets of ordered pairs. So if we take a look at this first example here, A, we have the set of students, right? And I can tell it's a set because of the set notation with these curly braces on either side. So a set of students, and that set is being mapped to the current grade in this class. So for example, a student, if I was going to make an ordered pair, a student in this class might be named Ben. Okay, so I have a student named Ben, and maybe Ben's current grade in this class is an 86%. Okay, then another element from my set of students might be Sue. Okay, and Sue, let's say Sue's current grade in this class is also an 86%, right? Is that possible that two different students in a class could have the same current grade? And yes, it is possible. Okay, then if I have another student, maybe this student is Tom. Okay, then let's say Tom has a 94% in this class. Okay, so there's 3 examples of ordered pairs. And if I take an element from the domain of students, so if I take an element from the domain, which is my list of students, domain, and I map that's what the arrow says, map it onto an element of the range. And the range here is the current grade in this class. So domain maps to range. If I want to know if this relation is a function, I have to decide, is it possible for a student in the class to have more than one current grade? And that answer is definitely a no, right? Ben can't have an 86% in this class and at the same time have a 90 in this class or a 74 in this class. Ben can only have one current grade in this class. Now, it is possible that maybe I have another student named Ben who has a different grade, but that would be a different student, right? Just because they have the same name doesn't make them the same student. So since it's impossible for the same student to have more than one current grade in the class, this is a function. So it says to circle the functions. So I would go ahead and circle the relation of student to current grade in the class as a function. Now, when I look at example B, my domain is the age of the student and the range. Oh, I lost my pen. Let's get my pen back. So the domain of a student, the domain is the age of the student, and then the range is the sophomores. So students who are sophomores. Okay, so let's think of some ordered pairs. So age, let's say there are 16 would be an X, right? That's an age of a sophomore. So let's see, somebody from the element of sophomores might be Tanya. Okay, so Tanya is a sophomore who is 16. Okay, now could there be another sophomore in our school besides Tanya who is 16? And that's for sure true, right? I could also have Tabitha be a sophomore at the school who is also 16. And I might have another 16-year-old named Ben, right? I could have a whole lot of sophomores that are all 16 years old. And same is true for 15 years old, or whatever common age is among sophomores. So because I have two x's, or one x here, the same x, two ordered pairs that have the same x but different y values, this is a relation only, right? This example B, age mapping to sophomores, is not a function. Okay, so now let's take a look at these mapping diagrams. So in a mapping diagram, which hopefully you've seen before in Algebra 2, you have two ovals or two sets listed, and the domain is the first oval or set of numbers. And then the range is found in the second set of numbers or elements. These could be words as well. So whenever I look at a mapping diagram, the arrows show the relation between those elements. So for example, since there's an arrow between -1 and -1, that would represent the ordered pair -1, -1. And then from 0 in the domain, that's mapping to -2 in the range. So the ordered pair 0, -2 would be in this relation. 1 also maps to -2. So 1, -2 is in this relation. 2 maps to 1. So 2, 1. Oops, my computer is dragging, so things aren't writing very quickly. Let's try that again. So we have the point 2, 1, and then 2 also maps to 3, so we have the ordered pair 2, 3. Now, if we want to decide if this mapping diagram is showing a relation or a function, we want all of our x's to have mapping to their one and only true y. So the problem here is going to come with 2, because it's mapping, this one x of 2 is mapping to a y value of 1 and a y value of 3. And that means this is a relation but not a function, right? Because it it's got one x with two different y's. Excuse me. Now when we look at the mapping diagram in B, 0 maps to -1. So that's 0, -1 as an ordered pair. 1 maps to 3. So 1, 3 is an ordered pair. 2 maps to -2. So 2, -2 is an ordered pair. And then our last ordered pair, 3 maps to -2 as well. So 3, -2 is an ordered pair. And in this relation, we can see that all of the x's are matched with one and only one y. So there's one arrow coming from each x value, right? That makes this a function. Each element of the domain is paired with one and only one element of the range, right? When we look at the arrows in A, which was not a function, we saw that the element 2 in the domain had 2 arrows coming out of it, not just one. So that's a method you could use to quickly spot when a mapping diagram is showing you a function or a relation only. Okay, so now in the last set of examples that we want to look at on this page, we have scatter plots. Okay, so everywhere there's a point is an ordered pair that's part of this relation. And whenever you have a graph of data, you can use the vertical line test in order to see if it is a function or not. So I'm going to go ahead and grab a vertical line here and I can see here at -2 that passes the vertical line test. Here at -1 passes the vertical line test. But when I draw a vertical line at 0 here on the graph, I can see that I have 2 points. So the one x coordinate of 0 produced 2 different y values, right? 0, 2 and 0, -2. And that's a problem, right? That fails the vertical line test, and so this is not a function. Okay, when I look at b, right here, I pass the vertical line test, pass, and all of these individual points on this graph, ordered pairs on this graph, they all pass the vertical line test. They all have each x with its very own one and only y, and so b is the function. And so we go ahead and circle that. Okay, now I'm going to go back real quick and talk about the domain and range of A and B as well, because we did for the other ones. So in these sets here, the domain was listed first, and then the arrow pointed to the range. In the mapping diagram, same thing, domain was listed first in the bubble, and then it mapped over to the second grouping, which was the range. In a scatter plot, your x coordinates of those ordered pairs are your domain, and the y coordinates of the ordered pairs are your range. And we list them in order from least to greatest in set notation with no repeats. So we use a squiggly or curly bracket here called a brace to indicate that this is a set of numbers. And then I start with my lowest x value, which is at -2. Right? And then I list all of my x's until I get to the highest one. So -2, then -1. Then there was an x at 0. And I only list them once, right? Even though 0 had 2 ordered pairs, I only list it the one time. And then +2 is the domain. Okay, and then I close that with a curly bracket called a brace. The range, now we're going to list the y values from least to greatest with no repeats. So the lowest y value that I have here is a -2, and then -1, and then the next one is 0, and my last y value here is a 2. And then I close it with a curly brace. Okay, in the scatter plot B, my domain is lowest x value is -2. Then I have another here at -1. Then 0, +1, +2. And then I close my curly brace. The range for this data in the scatter plot, I start with the lowest y value, which is -3. And then I have nothing in between here. The next time I have a y value is at 0 along the x-axis, and then I have a y value here at 1. So in this function, because remember it passed the vertical line test, domain of the set of numbers -2, -1, 0, 1, and 2, but the range only has 3 elements, the set -3, 0, and 1. Okay, so hope that helps, and that's the, I think the last page in our notes booklet was example 4 for domain and range of discrete relations and functions.